This is good news for customers who is processing heat-resistant alloys and titanium alloys. We will explain how the new DS1 coating improves the tool life of titanium processing. At first, we will explain about titanium alloys. Titanium alloys are often used in parts for aircraft, semiconductor manufacturing equipment, and medical devices because of their excellent heat resistance. This excellent heat resistance is the reason why it is called a difficult-to-machine material in cutting. Next, we will explain about problems of processing titanium alloys. With normal work materials, cutting heat escapes into chips and does not accumulate on the cutting edge. However, different from normal material, cutting heat remains in the tool when the machining of titanium alloy because it has excellent heat resistance and low thermal conductivity. As the result, wear progresses quickly, and tool life will be shorter. Lower tool life leads to higher tool costs and increased setup time. Then, Die-Jet solves the problem by using a new coating, DS1 coating. From now we will explain about features of DS1 coating. The cross-sectional view is shown here. DS1 coating has achieved a longer tool life in the processing of difficult-to-process materials by adopting high welding resistance and low chemical reactive coating highly adhesive on a substrate carbide that is suitable for each application. DS1 coating achieved excellent surface smoothness by adopting unique coating process which prevents welding. Conventional coating methods show tiny particle protrusions called droplets, whereas the DS1 coating has a smooth surface without droplets. The smooth surface prevents welding between the tool and workpiece, significantly improving tool life. Now, let's check the amount of tool wear relative to the cutting length by machining T6L4V. We will explain about cutting conditions. Cutter is SKG09 type which specialized for difficult-to-cut materials. Feed speed is 1600. The axial depth of cut is 0.8. The SKSG09 type can machine difficult-to-cut materials stably by adopting multi-flutes geometry with small inserts, a straight edge shape, and a strong axial rake angle to reduce cutting resistance and to provide excellent cutting performance. The process shown in the video is 47 faces of 50 square centimeters per face, with an axial depth of cut of 0.8. What is the wear condition when a total of 188 cubic centimeters chips are removed? The vertical axis shows the maximum flank wear, and the horizontal axis shows the number of cutting surfaces. There is a large difference in the amount of wear between the conventional product and the DS1 coating at the initial stage of wear on the first surface. This difference is due to the adhesion of the DS1 coating. While wear of conventional materials progresses significantly from the point of 20 surfaces machining, wear of DS1 coating is slowly. When machining 47 surfaces, the amount of wear is reduced to about 0.1 with the DS1 coating, compared to about 0.3 with the conventional product. The difference in wear is clear in the photos and shows the high performance of the DS1 coating. Here is a summary of the DS1 coat that we introduced today. Smooth surfaces with no droplets, excellent adhesion, and low chemical reactivity of the coating, which prevents peeling off, reduce cutting resistance and cutting heat and extend tool life. This is a presentation of tool life improvement with DS1 coatings.